Howdy folks, I'm Medalla, and in this video, I'll be teaching you on how to solve a linear programming problem using Excel Solver and GeoGebra. To start off, let me read the linear programming problem. Kelson Sporting Equipment Incorporated makes two different types of baseball gloves, a regular model and a catcher's model. The firm has 900 hours of production time available in its cutting and sewing department, 300 hours available in its finishing department, and 100 hours available in its packaging and shipping department. The production time requirements and the profit contribution per glove are given in the following table. Assuming that the company is interested in maximizing the total profit contribution, answer the following. In this linear programming problem, there are 5 requirements, and the first in line is what is the linear programming model for this problem. And to get the linear programming model, we need first to determine the variables. And based on this table, we are actually given with the variables, which are the regular model and the catcher's model. You can derive the variables into x and y, simple, or you may use any letter you want. But for me, I will just use R for regular model and C for catcher's model. So let's put it in here so that we will not forget it. So we have variables R equals to regular model and C is equals to catcher's model. Here we go. Here's our variables. And now we can proceed to the formulation of the linear programming model. For us to formulate our linear programming model, we need first to construct our objective function. And in order for us to construct our objective function, let me reread the linear programming problem. So it states here that the company is interested in maximizing the total profit contribution. So there's a clue here, maximizing the total profit. So that is the objective of the company. And so in this table, there are these figures, $5 and $8, wherein the $5 represents the profit per glove on the regular model, and as for the $8, it represents the profit per glove on the catcher's model. And so, with that being said, we can now construct our objective function. So let us type in max, because we are to be maximizing it, the profit, And so we input 5, that is the profit per glove of the regular model, and then R, and then plus sign, and then 8, that is the profit per glove of the catcher's model, and then C. Here you go. That is our objective function. And the next in line would be our constraints. For us to formulate our constraints, still we need to get back to our problem here. So it states here that the firm has 900 hours of production time available in its cutting and sewing department. And based on this table, we have figures 1 and 3/2. That is under the column of cutting and sewing department, wherein 1 represents the regular model and 3/2 represents the catcher's model. As for me, and for the purpose of uniformity, and since we are to be using Excel Solver, right? So we need to interpret all of these data, like these ones, the fractions, into a decimal form. So 3/2 is 1.50, and so with those data, we can now formulate our first constraint. So for our first constraint, well, firstly, we need to type in ST. ST stands for subject to. And then we have 1, then R. R for the regular model, right? And then plus sign and 1.50. That is the decimal form of 3/2. Then C. Then less than or equal to 900. So why do we use less than or equal to sign? Because of the fact that it's stated here that 900 hours of production time available in its cutting and sewing department. That implies that that is the maximum number of hours of production time available. Thus, we use the greater than or equal to sign. I mean less than or equal to sign. Next, we have the finishing department. 300 hours available in its finishing department. And we have these figures 1/2 and 1/3, which are well, I mean 1/2 for the regular model and 1/3 for the catcher's model. And so, since we have these figures, we can now formulate for the second constraint. So 1/2, that is 0.5, and r plus sign equals 1/3, that is 0.33333, but we can cut it into 0.33. So 0.33c and less than or equal to 300. Okay, now we're down to our third constraint, which is this: 100 hours available in its packaging and shipping department. And in the packaging and shipping department column, we have 1/8 for the regular model and 1/4 for the catcher's model. And so we derived it again into decimal form, and that is for 1/8, that is 0.125, and as for 1/4, that is 0.25. Okay, so 0.125 r plus sign and 0.25 c less than or equal to 100. So now we are finished with our constraints given in just basing on this data. But in a linear programming problem, we need to include the non-negativity constraint. So the purpose of the non-negativity constraint is because of the fact that the number of hours can never be negative, but it can be 0. So in order for us to construct it, all you need to do is to copy the variables r, comma, and c, and greater than or equal to sign, and insert 0. So again, why is it 0? Because hours can be 0, but never negative. Now we are finished with our first requirement, linear programming model. So here it is. And now we're down to our requirement B. Find the optimal solution using the graphical solution procedure. How many gloves of each model should Kelson manufacture? So for us to find out the data that we should input in here, we need to we need to have our variables. We need to insert our variables. So let's first get into it. So variables, and then we have R, which stands for the regular model, and the C, which stands for the catcher's model. And for the purpose of since we are using Excel Solver, rather, we will be inputting 0 on this one. And later on, if we get into the solver, the zeros will be transformed into the answer of this one. So let's just go with it. And then let's then get to the objective function. So our objective again is to maximize, and then we have it like this. So equal sign, and then 5 asterisk, that is multiply, and then click this one because that is R, and then plus sign, and then click 8, and then asterisk, and then click C. Voila. And we're down to the constraints. So in an Excel, in here we actually have 4 constraints, right? But for the purpose of solver, we need to have 5 constraints. So why do we need to have 5 constraints? So as you can see here, we input a comma between R and C, and so for the purpose of solver, we need to make them one-on-one, or we need to separate them rather. So we have 5 constraints all in all. So 1, 2, 3, 4, and 5. Then we input a what you call this, equality here. Then RHS, which stands for the right hand side. So let's get started then. So for the first constraint, we have equal sign 1 and asterisk r, then plus 1.50 asterisk c, and then the inequality sign, so we use less than or equal to, then right hand side, so just the figure the figure that is in the right of the inequality, that's 900. So yeah, that's it. And just follow what do we do in the first constraint to the second to the fifth constraint. So equals 0.5 an asterisk r, then plus sign 0.33 asterisk c, voila, and less than or equal to, then we have 300 for the right hand side. And for the third constraint, 0.12, I forgot to input the equal sign. So equal sign 0.125 and asterisk r, then plus sign, and then 0.25 asterisk c, and yeah, here we go. And less than or equal to sign, and 100. And for the non-negativity constraint, so equals r, and then greater than or equal to 0. And the last one, we have the c. Oh, equal sign, and the c, then greater than or equal to sign, and then 0. So now we're done with with inputting the data that we need for the solver. And so we got into the solver. So if you are not familiar with solver, and if your Excel, if your Excel does not, there's no, what you call this, no. If your solver wasn't yet activated in your Excel, so all you need to do is go to File, then Options, and then go to Add-ins, and then select Go. Make sure that the drop-down menu, you get to drop-down menu and select Excel Add-ins, then press Go. And then if this is not checked, make sure to check this one and then press OK. In my case, I will no longer be doing it because I activated it. So let's proceed to the solver. So let's go to the Data tab, and then let's get to Solver. And then, as you can see here, we have set objective to by changing variable cells subject to the constraints. So let's get started with the set objective. So our objective function is in here, right? So let us click this one, and then that's it. And then we are to be maximizing it, so yeah, we select this one. And if you are to be minimizing a profit contribution or whatnot, then just select min. And for the changing variable cells, all we need to do is to click these two. So yeah, that's it. And for the subject to constraints, well, we will be basing it here. So all you need to do is to click add, and then let's have it this way. Click this one, and then you can choose the inequality sign and in the drop down menu. So here, less than or equal to, and the constraint we choose are 900, and add, and until you got into the fifth constraint. So yeah, this one, inequality sign, constraint 300, add this one, inequality and the constraint 100, add, and then to the fourth constraint, and this now we will change the inequality sign to the greater than or equal to sign, and then the constraint here. And lastly, we have the fifth constraint, then greater than or equal to sign, and the constraint. So once you are done, all you need to do is you no longer click the add, rather you need to click the OK. So OK. And then make sure to check this one, make unconstrained variables non-negative, and then here, as you can see, it is like a drop-down menu, and I already inputted simplex LP, but the default here is the GRG nonlinear, and so you need to change it into simplex LP. LP again stands for linear programming. And the moment of truth, just click solve. So this is the ones that will appear on your screen, so just select OK on that one. So here you go. We already have the values of our, the 0 values have been inputted with the values, with these values, right? And so, as you can see here, the values are 501.49, blah blah blah, and 149.25, blah blah blah. And so, again, the question here is, how many gloves of each model should Kelsen manufacture? And, of course, we're talking about gloves here. So, gloves can never be a decimal point, right? But it should be a whole number. And so, all we need to do is to round these values off. Okay, so round off, and then if you round this off, it should be 502 and 149. Okay, so that's pretty much it. And again, as promised, I will teach you on how to solve a linear programming problem using GeoGebra. And for us to get into it, I mean just to prove it, So yeah, go to GeoGebra. So all you need to do is to go to your browser and then search GeoGebra. And then choose the classic one. And let's wait for a minute. And here you go. So this is the first thing that will appear in your screen. So this is the default screen of GeoGebra. So I'll just maximize it. So the first thing that you need to do for you to solve the linear programming problem using the GeoGebra, I mean not to solve, but to find the optimal solution, is that you need to input the constraints. So as you can see here in the problem, we are using, or I am using rather, R and C for the variables. But in GeoGebra, the variables are to be inputted in X and Y. Okay, so to avoid confusion, the regular model should be the X one, while the Y should be the catcher's model. So let's proceed. So the first constraint that we have is this one. So 1x, so 1x plus 1.50 y and less than or equal to 900. And then we get to the second constraint here. So 0.5 x plus 0.33 y less than or equal to 300. And then the third constraint, we have this. So 0.125 x plus 0.25 y less than or equal to 100. And then just like what we did in here, we need to separate the non-negativity constraints. So it goes like this. X is greater than or equal to 0, and Y is greater than or equal to, greater than or equal to 0. So you already now inputted our constraints, right? And so the second thing that we need to do is to input again the constraints, but instead of having it into its inequality form, we need to substitute it into an equal sign. So let's get started. 1x plus 1.5y equals 900. Well, you can just duplicate this one to be more efficient. So duplicate input and then just change the equal sign. Then we have the third constraint, duplicate input. Yeah, and fourth input. Okay, and then the fifth input. Y equals 0. So we're now done with the second requirement. And for us to get to have this, this clear interpretation, just put out the colors in here. Put out the colors in here. Just click these one. So as you can see, there are lines, So for the third one, for the third thing that we need to do is to have it this way. So we combine these. So all we need to do is to type in A and then double ampersand and then B double ampersand double ampersand C double ampersand D double ampersand and E, and then here we go. So as you can see, there is this shaded part, and these shaded part is the feasible region. And so the next thing that we need to do is to get the values of these, because these are the ones that intersects within the feasible region. Well, there's an exception here because this is actually 0. So it means that the values are null in this area. So it is not a feasible region, regardless of the fact that it is in the feasible region, technically. So we need to find the values for these one. And so let's get started. So let's have the first one. So intersect and then choose object. So let's have EQ3, equation 3, this one. And then EQ4, or equation 4. And so we have this one, right? So let's have, name and value, okay. And then we get to the next intersecting line, so intersect. So yeah, and then equation 2, then equation 3. So I'll just base it here, so yeah, and voila. So go to settings, name and value, next. And for the third intersection line, or intersecting line, intersect, then EQ2 and F. So here, got it here. So yeah, we're actually done with the labeling of the intersecting lines, right? And so since these are the 3 intersecting lines with their values, so the next thing that we need to do is to find out which of these three are the optimal solution. And since we are talking about maximizing, the value that is the highest should be deemed the optimal solution. So let's have it this way. So again, please disregard these for a moment, just for the purpose of illustration. Although we already knew that the optimal solution are these values. So just for illustrative purposes, I will I will illustrate. So okay, wait a minute. So let's have it here. So let's type in sum. So let's just, okay, so before I forgot, so for us to find the optimal solution again, so we need to substitute the variables r and c into these figures. Okay, so let's hop in. So 5r, I mean not 5r, but 5 times 0 plus 8 times 400. Okay, so 5 times 0, that's actually 0, and 400 times 8, that is 3,200. And the next one, we have the second intersection, so 5 times 501.49 plus 8 times 149.25. And if we were to be solving it, 5 times 501.49 is 2,507.45, and 8 times 149.25, we have 1,194. And we add them, we got 3,701.45. And we got to our last intersecting line. So 5 times 600 plus 8 times 0. So 5 times 600 is 3,000, and 8 times 0 is obviously 0, and the sum is 3,000. And as you can see, if you will to be comparing these three figures, well, obviously the highest number, or the highest figure, is this one. And so it is 100% verified that this is correct based on our semi-manual computation using the GeoGebra. So that should be the total profit contribution based on the optimal solution. So yeah, that's pretty much it. So we're now done with requirement B and requirement C. So by the way, if you get confused, the answer for this one, how many gloves of each model should Kelson manufacture? Well, these are the answer. Okay, again, why do we need to round this off? Because obviously gloves can never be a decimal number. It should be an integer, a whole number. Okay, so we're down to our requirement D. So how many hours of production time will be scheduled in each department? So for us to compute the number of hours of production time to be scheduled per department, we need to make a schedule. And in general, we need to substitute the constraints with the optimal solution, excluding the right-hand side and the non-negativity constraints. So let's get started. So let's type in department, and then let's get back to the table. We have cutting and sewing, finishing, and packaging and shipping. So cutting and sewing. Oh, I forgot the G. Then finishing and packaging and shipping. Then in the second column, we input production time hours. Then the maximum number of hours, and then hours and minutes. Okay, so the next thing that we need to do is to derive again our constraints, again excluding the inequality and the RHS with these figures. Okay, so 1 equals 1 asterisk R plus sign, and then wait a minute, 1.50 asterisk C, and have this one. And as for the second constraint of the finishing department, so equal sign 0.5 asterisk R, and then plus sign 0.33 asterisk C. Voila. And in the third constraint, packaging and shipping, so equal sign 0.125 asterisk R, and then plus sign 0.25 asterisk C. And here you go. So now we actually have the values of our production time in hours, right? And for us to really determine the hours and minutes, we need to derive these decimal points into hours and minutes. So 725.3731343 is actually 725 hours and 22 minutes. And as for this one, that is 300 hours and 0 minutes. And the last one, in the packaging and shipping department, we have 100 hours and 0 minutes. So those are the answers for this question. How many hours of production time will be scheduled in each department? Cutting and sewing, we have 725 hours and 22 minutes. As for the finishing department, we have 300 hours and 0 minutes. And in the packaging and shipping department rather, we have 100 hours and 0 minutes. And now, we are down to our last requirement, which is what is the slack in each department? I mean slack time. So before we proceed to it, let us define first what is slack time. So slack time is the amount of time a task can be delayed without causing another task to be delayed or impacting the completion date of your project. So all we need to do for us to get the slack time in every department is we need to subtract the production time in hours from the right hand side, or the maximum number of hours per constraint in each department. Again, we need to formulate a a schedule on this one. So let's just copy this, and then we add production time in hours, and then we have maximum number of hours, max number of hours, and then the slack time, and hours and minutes. So again, just an overview. All we need to do is to, we already have the amounts, right, of the production time in hours and maximum number of hours. I mean in the, yeah, we have these values already, and all we need to do is just to deduct this. So let's input it again. So 1 point, is that 1 point? Wait a minute. Okay, that's 1. Sorry. So 1 and asterisk, then we input R, and then the plus sign, and then 1.50 asterisk and C. Here we go. And for the finishing department, we have 0 0.5, 0 0.5 asterisk R, and then the plus sign, and then 0 0.33 asterisk C. Okay, and for the last one, last department, so 0 0.125 asterisk R and plus sign 0 0.25 asterisk C, and here we go. So the maximum number of hours is the right hand side. So we can just base on this data. So we have 900 for the first constraint, 300 for the second constraint, and 100 for the third constraint. Again, we don't need to include any more than non-negativity constraint for this particular question. So 900, 300, and 100. And for the moment of truth, we need to deduct 700 to, the production time of hours from the, we need to deduct the maximum number of hours from the production time. Yeah, we need to deduct this too. So yeah, let's get started. So equals here, and then minus this one. So yeah, we got this one, and equal sign, press this one, and minus this one, and here equal sign and minus this one, and here you go. So these are the slack time, right? Slack time, and so we already have, yeah, we already have the slack time based on what we just did, and so we need to derive it again, not the decimal form of the slack time, to hours and minutes. So 174 hours, 174.6268657 is equivalent to 174 hours and 37 minutes. And as for this one, well, it's obviously 0 hours and 0 minutes, and just copy this one because, well, no, sorry. So 0 hours and 0 minutes. So we're done answering all the requirements. So just an overview of it. So these are the linear programming model. So yeah, this is the answer for requirement A. And as for this one, this is the answer for requirement B. And as for this one, for the requirement C, what is the total profit contribution Calcin can earn? This is the answer, 3,701.45. Well, I guess in the problem, it doesn't state, oh, okay, so it has been stated. So just don't forget to put the $sign, and that also applies to this one. $sign. Okay. And then for the how many hours of production time, so these are the answers. And for the last requirement, the answers are this one. So that's the end of the tutorial, and I hope that you have learned a lot from this tutorial. And if you have any question, just comment in the comment section below. And that's pretty much it. Again, I am Medalla, and see you in the next video.